All right. All right. All right. Good morning. Hello. I guess I should leave a little bit more of a warm-up period in the beginning of these. You know what I'm saying? You know what I'm saying? All right. That's going to be fucked up. All right. Good morning, good morning, good morning, good morning. Good morning, good morning, good morning. I'm just copying notes over from my other computer. You know what I mean? You know what I mean? Alright, so after I got off stream last night, I was kind of like, damn, that did not go how I thought it was going to go. Which is fine. But I didn't really have a good idea of an approach as to how I was going to work through the how I was going to work through this cooler thing, right? So I guess it might make sense. How do I want to? I'd like to draw. I'd like to maybe just draw to talk through it. All right. So we're gonna have this cooler manager class. So I don't think in the end that this is actually gonna be a class, because what all it really does is manage. Excuse me. Sorry. Manage these pins here. So on the intro or on the init, you pass a list of numbers, right? These map to the actual pins that are attached to fans, right? So these are those MOSFETs. Actually, don't have that open. I might want to get that open over here. So there's a set of pins that are attached to the MOSFETs, which are then attached to the fans. So this is not too bright. Maybe I want to do this. Maybe. Backlight it a little bit better. Hey, that's not bad. That's a little bit better. All right. So, yeah, bump the brightness up a little bit. All right. A little bit better. All right. Sorry about that. So we have those MOSFETs. All right, we can switch over to that. So we got these pins that we know are attached to MOSFETs and then attached to fans. So the cooler controller, all it knows is that there's a list of fans, or there's a list of pins rather, that are going to eventually drive fans with PWM. Yikes. So I'm going to close that. Alright, so that's all it knows. And what its job is to manage those pins. That's it. All right, so I do want, so this function power, or this method. All right, so if all this thing is doing is operations, is just modifying these pins, then we could, instead of doing a class, we could just do a set of operations on a list of or on a list of PWM controllers or something like that. We don't necessarily need to make it a class. And I think I'm gonna do the development in object-oriented style, but I think eventually I'd like to move it to more functional, where it's just methods on, or it's just functions that accept that list of PWM controllers and then do things to it. Because the interesting thing, if you look at the PWM controllers, if you open that class up, so if we do set up PWM and then this PWM thing, this lets you, with a single, with no argument, the current or the duty cycle is returned. So you're already maintaining state as to what the PWM is set at inside of that object. So you don't really need the internal state of, we don't really need that much state here, right? And then in the main, this cooler manager thing is going to get modified by a PWM or a PID controller. And that definitely needs internal state. So, maybe, like I said, I'm going to develop this in object-oriented develop this object-orientedly and then hopefully transition to something more functional to try to, have fewer classes here. All right, so this power function. This is kind of where I was flailing a little bit. So I think what I want here, so this is going to be what is controlled. This is going to be the method that is exposed by exposed to the PID controller. So it's gonna. This is what the output of the PID controller is going to take. So another thing I wanted to try to implement, if it was easy, is rotating the active fans. So not spinning, but like say you have one. So things are set such that you only need to have one fan spinning to keep the GPU cool. Like say the GPU is idling, you need to only have one fan spinning. Providing a rotate method to switch which of the three fans it actually is, like over a period of time, as to not wear down one fan more than the others. That's another thing that I would want here, just to make sure that the fans wear in evenly. Yeah, all right, so, but again, you can read off the PW. You can read off these objects. So let's actually annotate this. So this is going to be a list of PWM. So you can read state off of these. So you don't need to like keep track of who's active. You can read that off of the pins at whenever you want. So this again doesn't need to be a method. This whole thing doesn't need to be an object, but it's just going to make it easier for me to write and then to port over to something different. All right, so this power function. So this is kind of where I ran into a wall last night. So basically, what I think I want to do is and I tweeted about this. I think I want to do. All right, so let's first figure out. Okay, so how does power? So we're gonna do. So new power is gonna be a float, right? So I'm gonna stick with this, right? So new float between 0 and 1. 0 maps to a single fan is spinning as slowly as possible, and 1 maps to all fans spinning as fast as possible, right? So what happens in between? Okay, that's where we can get really interesting, right? So I think what I would like to do is oh, he's back, Tech, my dude. Yes, he's back. Yeah, I'm gonna be on for a while. Unless okay. The goal for the stream is to finish the control software. If I'm able to somehow like swish, I might hop off early, but I'll probably just stay on until you come back. Let's just say, yeah, I'll stay on. Just come back whenever. No worries, bro. Good to hear from you, man. Real quick, how are you feeling? Ladies and gentlemen, Tech is back. The prodigal son returns. I gotta mod you too, bro. How do I do that? I don't know how to use this website. Whatever. I feel really good. Yes! Yes! Healed! Awesome. Good to hear, bro. Yeah, no worry. Take your time. I'll be on. I was on short last night because I was fucking up, but I'm feeling much better today. So let's do it. All right, so where are we? So this power function, right? So it's going to be, so 0 is going to be 1 fan spinning as slowly as possible. 1 is going to be all fans going as quickly as possible. In between is the interesting. There's a lot of stuff we could do in between, right? We could have there's a lot of stuff we can do in between. So I think what my goals are. So the goal, yeah, it's kind of what I say up here. So the goals of this thing is to have each of the individual fans spinning as slowly as possible. 3 fans spinning slowly is better than 2 fans spinning quickly, right? This is because the sound factor, right? Right, we don't want these to make as much noise as they could. So, basically, the way I'm going to think about this is power is going to convert this float to ADC, to a sum total of ADC counts, right? So I can draw this, and I should. All right, so let me try to draw this. All right, this is new technology for the motherfucking stream. Alright, so MS Paint Untitled. Paint Bucket, Bueller. Alright, wait. I'm debugging my drawing tool. I'll try closing this. Don't save. Paint. My super advanced MS Paint. Drawing situation. Alright. Check. No, dude. No. Why was this working the other day? It's not working now. Fuck. Well, I guess none of this is working, eh? Okay. Sorry, ladies and gentlemen. Let me try saving this. Save as stream.png. Alright, interesting. So this is not able to see. So what if I take the filter off? Remove filter chroma key. Okay. So that was working. Alright, so what I'm gonna do is fill, solid color. Alright, so what I'm gonna do, so the chroma key was fucking up. Custom color, select color, right. Pick screen color, bow. Alright. And then we should be able to do this. Maybe? Maybe? I wonder why it's not working. So that works. But I can't key out that color that I want. So what was working the other day. Alright, so let me do this and then let me do that. Pow. Okay, so all right, so it's just got to be green, which is a little bit weird that I can't do white. And let me try blue. Let me try this blue. So I'll do you this, you this. Fill, solid fill, fill. Okay. Okay. Okay, wait, let me do a little bit. Yeah. Close that. Alright, so then I gotta do chroma key. Key out. Select color, pick screen color. Okay, and then now I can try drawing. Maybe? Yeah. Yeah. All right, weird, dude. I guess not that weird. I guess not that weird. All right, so what I want to do here, get this, is map, or what I think is going to work. I don't know if this is going to work, but what intuitively I think is going to lead to a good result is like doing a cost, ooh, Jesus Christ, is like doing a costing thing. Oh my God. Okay. Okay, so a cost function. Right. So if it's like, so the input range is going to be from ooh. Does not like my multiple desktops. All right, so where are we? Over here? So we want to be like over here. So it's like, this is the drawing area. Okay, okay, okay. Pause this for a sec. Stop. All right, so input range is going to be from 0 to 1, and then the output range is going to be from the like this, it's going to be an ADC count, or it's going to be in PWM duty cycle values. It's going to be the function it's going to be in these values. So the lowest number is going to be like the number of counts that is the lowest audible fan speed in counts. So call it 40,000. 40K. And then the upper is going to be the maximum speed. So the maximum value, I think it's 60 something, 63K. 63K times the number of fans. Right? So this is, oops, I deleted the S. So this is all fans full speed, and this is one fan slow speed. So this is in float. Oops. And this is in counts. Right? So then we get some number in here. We get some number. So say that number is all right, so actually first let's just so this 63K number is actually, so 63 times 3 is 189K. Okay, so say the number that we land on. All right, so okay, cool. So say we want to do halfway in between those two values, right? So 189. So okay, so it's going to be 189K minus 40K, and then take that number divided by 2. So 7, yeah. Right. 74,500 would be halfway in the middle. So this number, right? How do we, okay, so this is in counts. This is this is in the U16 counts, right? Between the three fans, there's a number of ways that we could get to this number. So, and that's kind of where this integer partitioning stuff comes in. So I think it might make, well, let's just keep using, right? So, okay. So intuitively, all right, so there's a little bit more info here, right? So as this value changes on the fan, as we go back and forth here, right, the audio impact is going to change. The volume's going to change, right? So, how do I say this? So the more that the fan, okay, so all right, I'm getting ahead of myself. So we need to construct this number, right? So I'm gonna redraw this smaller and cleaner. I'm gonna redraw this. Does everyone understand, chat? Do you understand what I'm talking about? All right, so yikes. Power is from 0 to 1 in counts. That's from 40K to 189K. All right, so when we get a number here, so let's actually fudge let's fudge these numbers a little bit. So let's say this, just for the sake of being able to work through this a little bit easier. So say the counts for lowest acceptable volume is 1,000, and the counts for highest speed is 3,000 times 3, so 9,000. Okay, so so say we have a number 4,000 in here, halfway between. Okay. All right, this is a little bit easier to see. All right, so we have this 4,000 number. Okay. So, and we have 3 fans to achieve this number of counts. So we could do fan 1. So fan 1 does 3,000. Fan 2 does 1,000. And fan 3 is off. Or we do fan 1 does like 1,500, so the top is 3,000. Second fan does 1,500. Third fan does 1,000, right? These all equal 4,000. So there's a lot of ways you can build these numbers up. So how this breaks down is important to us. Okay, so where can I draw? Draw there. Can kind of draw there. Okay. All right. So this is kind of the crux of the whole thing, right? So the fans are going to have, like, for each different speed, they're going to have a different cost sonically. So between 1,000 and, like, say 1,500, 1,000 to 1,500 is, like, very quiet. Ugh, God. I'm going to switch thicknesses so I can get more on the page. So 1,500. Okay, so that's actually much better. So 1,000 to 1,500. So this is, remember, slow as possible. All right. So in this range, we're, like, very quiet. Between 1,500 and 2,000, it's, like, tolerable. And then from 2,000 to 3,000, it's too loud. So we always want to try to optimize to have the lowest value in this breakdown. We want to have as many values in the tolerable range as possible. We want the breakdown that produces the lowest number individually, the lowest numbers individually. Okay? I guess you can't use sum, but the lowest, because the sum is always going to be the same. So because here in this 4,000 example, 4,000 divided by 3 isn't a round number. It's like, what we want is actually ooh, can't see that shit at all. Can't see that at all. So what we actually want, what? Am I off the side? I'm off the damn side. So what we actually want, what? Weird. Alright, it doesn't like, does it not like, doesn't like purple. Likes that. Doesn't like that. Okay, orange works. So, what we actually want is like 1,333 each, right? Because that puts us in this range. So, I guess what is that? But at the same time, so let's take another example of this. So at the same time, alright, so knowing that we have these values, let's take the 1,000 example. This is kind of a hard problem. So 1,000. So you could break 1,000 between 3 numbers, each of them spinning at 333 ish. You could do 250, 250, 500, or you could do 1,000, 0, 0. All equals 1,000. So we want this case here. We want a single fan spinning below the and like in the top, like one fan in the tolerable range is fine. So we need to figure out what this is actually defined as. We need to figure out what this metric is. I think it might be average. No, it can't be average. It's always, the average is going to be the same. Because it's 3 fucking numbers. Yikes! Alright, so what metric are we getting? So I need to be able to go from one of these combinations to how good it is. Getting the combinations I don't think is going to be impossible, or at least I found there's like a mathematics around doing that. So what numerically here makes the most sense? Maybe like sum of the squares. All right, we can kind of work this out in Python, I think. Because whatever the thing is gonna have to value lower numbers more. So if we have, let's just work through that thing from, oh fuck, I fucked it up. How does this look? I need to pull this up over here, because this could look just terrible. Oh, it doesn't look that bad. Damn, I look kind of rough though. Alright, so okay, so whatever this, oops, sorry. Whatever this calculus is going to have to value small numbers more. So we want a function that's going to make, in these two examples, is going to make the call that we want. All right, so I think I'm actually going to do this in an editor, so it's just a little bit faster. Even though this is kind of what REPLing is for. Alright, so, whoa, where is this? Alright, going away from there. Getting the fuck out of there. New Python file temp. Alright, so square sum. So this is going to be iter sequence. So this is going to be values is going to be a sequence. Ooh, sorry. A sequence of int or of, yeah, let's just do ints for now, and it's going to produce an int. So we're going to do return sum of value to the this value squared for value in values. Okay. If name equals main, print sum squares. So let's do the two cases, right? So we have A, we got B, we got C, which is the one we want. see. Alright, let's just run it. Ah! Why? Why are you like this? I think this is because I'm in the wrong directory. So if I do rename scratch. Actually, is there file, new scratch file? Same problem. I still don't really understand how to work with the MicroPython stuff, but that's fine. Ooh, okay. So that's the max. So alright, so I wonder if that follows for the other one. D 3000 1000 0 E 1500 1500 1000 F D E F. What do we think? If I divide this divided by 3. Okay, so maybe I do need to add All right, so this isn't super encouraging. So what this is telling me is that the squares thing works. Some of the squares would work, right? Some of the squares would work. But it doesn't really reward this case, which is what we want. I love that it chooses this one over this one, and it chooses this one over these two. So maybe we need to know a little bit more about the input number before we make this calculation. I think that's kind of the only way to do it. So if we know target is 1,000, so I'm having bad thoughts, like maybe I'm way over engineering this. But I think it's nice to, yeah, this is kind of what I'm doing today, so it's fine. All right. Let me take a quick little browse break. You know what I'm saying? Little scroll break. so huh. Okay, so the issue is that we would rather have this case than this case because this is of a certain value. This is of an arbitrarily low value. Okay, so $250, $255. Okay, so I guess all of these would be fine, but this one has one fan spinning, so it's like maybe it should weigh lower numbers differently. Alright, I'm slowing down here. This is no good. So and then the other thing is this. These two are just division. Right? So it's like a roundabout way of doing division. Oh no. Because like coffee. Fuck. Oh, okay. You know what I could do? You could go in and rank each number. Ooh, fuck. You could go in and rank each number. And then some. Oh, that's it. That's it. You could go in and rank each number. Sum the ranks and then find the minimum of that. Right? So that's kind of what we're doing. Fuck yeah. I think that's it. So this is rank 0, 1, 2. Oh, and then you could adjust these weights. You could adjust these weights too. Ooh! Okay, so this is going to be rank 1. 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 This is going to be... So there's 3, 3. And this is going to be 1. Zero, 0. Pick the lowest. Okay, so here. So we have to... Well, okay, so that's a new thing. We have to introduce that idea. Fuck yes. I think this is going to work. So this is rank 2. This is rank 0. Or rank 1 or whatever. This is rank 0. So 3. Okay. Wait. Delete. Okay, we want another step here. From like... Okay. Let's get the fucking eraser out. Let's get the eraser out. I'm stoked right now. This is weird because I have to erase with the green screen color. Okay, so we're okay. So so there's gonna be a table here. So it's gonna from 1,000 to 1,100, and then 1,100 to 1,500. And then 1,500 to 3,000, 3,000, oops, 3,000, 4,000, 4,000. Okay, wait, what did I say the top speed was? Fuck. So this should be 1,500. So the top speed's 3,000. To 2,000, 2,000, to then 3,000. So each of these has a different rank, and I can. So let's just make them linear for now. So this is going to be 1, 2, 3, 4. So this is rank, and this is count. Okay. So okay, so rank 0 is 0 only. That gets his special number. Okay, so let's do the ranks here. Okay, that looks like shit. Alright, so let's do the ranks here. What about pink? Also looks bad. It fucking also looks terrible. Looks like shit. Why does that look bad? Damn! Alright, we'll just do orange. Alright, so let's go through and do this ranking exercise on all these numbers to see if this works. Yes! I think this is gonna work. Okay, so this is 1. This is fucker. Alright. Wrong again. Okay. I need to add another rank. So 0. Okay, so 0 gets a rank of whatever. Of 0. And then from 0 to 1000. Okay, so now it's 1, 2, 3, 4, 5, 0. Okay, so now let's do it. So this is going to be... No, 0 to 1000 is 1. So let's rank these. 1, 1, 1, 1, 1, 1, 1, 0, 0. So we got winner over here. And then we got five, 2, 0, 3, 3, 2, 2, 2, 2, 6, 8, 7. This has got to be wrong. Oh, this. Wait. Shit. I'm erasing all of this and I'm redrawing it again because I feel that I have changed the rules too many times. Okay. So fan speed weight maybe. So 0. I'm gonna do Fibonacci numbers. And then this needs to be a constant increase in speed. So this is for 0, and then from 0 to call it 500 to 1000, 1000 to 1500, 1500 to 2000, 2000 to 2500, 2500 to 3000. So not moving, slow, fast as possible. So if we do Fibonacci, so 1, 0, 1, 2, fuck, 2, 3, 5, 8, 13. So that's how much the different speeds cost. This is like cost. And this is speed. Okay? So let's do two example just build-ups. So say we're trying to spin at 2000 at speed 2000. So we could do, and each fan, no. So we're trying to spin at 1000. And we know that a single fan spinning at 1000 makes no noise. So ideally, and we have 3 fans. So 1000, 0, 0. Another way you could build this up, 500, 250, 250. Another way you could build this up, 900, 50, 50. Another way you could build this up, I'm off the damn screen. Oh my god. No noise. Okay, so let me move all of this. Select. Okay. So let's do so say whatever the partitioner gives out. So okay, so we're trying to set to speed. Yikes. We're trying to set to speed 1000. Okay. So you can do 1000, 0, 0. We want this one to win. You could do 900, 50, 50. You could do 500, 250, 250. You could do 333, 333, 333. All of these add up to roughly 1000. So this is going to be the points are going to go in this box. Alright, so 1000. So that's 3, 0, 0, 900. So that's 2, 1, 1. $500. 2, 250, 1, 1. Same score. One, 3, 4, 3. Fuck! All right. So, chat, how do we... Maybe 0 should be a negative weight. No, I think it just should be... Alright, so let's just do it. Not inclusive on the outer edge. Let's make that rule. I know, inclusive. Inclusive on the outer edge. Okay, so go back and rescore this. I'm gonna use a different color too. Switch to orange. So switch to green. Does that come up? Nope. Brown. All right, that works. All right, so inclusive. So okay, so we're gonna say inclusive. All right, so 2, 0, 0. So 900. So 2, 1, 1. 500. 1, 1, 1. 3, 3, 3. 1, 1, 1. 2, 4, 3, 3. Okay, that worked. Let's try Each fan can spin at 4,000 or 3,000. Let's try 4,000. So what we want okay, wait. Let's try 6,000. Actually, no. Okay, so each fan can spin at 3,000. Let's try 3,000. One thousand, 1,000, 1,000. This is what we want to win. 2,000, 500, 500. $1,500, 1,500, 0. 290 or 2,900, 50, 50. Okay, so let's just point these. Two, 8. No, 5. 5, 1, 1. 3, 3, 0. Same score. It needs to be more than the ranking needs to be a sharper curve. 13. Yeah. One. So we got 15, 6, 7. Six, fucker. 6, 7, 6, 15. Who wins? These two are tied. These two are equivalent, although I want this one because it has more under 1,000 values. So this just shows me I need to increase that I'm going to save this. So approach.png. So what this is showing me is that this needs to be more expensive to move up this. To move up cost. The cost function needs to be, or the weights need to be bigger. So switch over to research. Wolfram Alpha, baby. X to the 3. Where the fuck the carrot? Oh yeah. Yeah. It's got to be something like this. It's got to be something like that. Oh. And I gotta set the speed values manually. All right, I need to go on break for a sec. Good shit.
If you're a Massachusetts homeowner that pays more than $67 a month for electricity, you may...
Okay, I'm back. Do a little updating. Okay. All right, so we can start to test and program this idea. Right? Okay, so okay, so we're gonna have weights. From 0 to 1,000, then from let's just take the example that I've been working through on paper. So 0 to 500. So okay, so there's 0. It's gonna have to check for 0 explicitly or whatever. This first cut. 500 to 1,000. 1,000 to 1,500. 1,500 to 2,000. 2,000 to 2,500. 2,500 to 3,000. Okay, so the actual weights we can calculate on the fly. So weights. So we'll call this is gonna be a dictionary. Oh no, it's gonna be I guess a dictionary. So value to range. No, so value to weight. So for range, nah, so for it's another word for range. For thesaurus range. Yeah, scope. For scope in ranges, weight ranges. So this is going to be a dictionary. And this is actually going to be, so scope index and enumerate. Scope index. Okay, so we're going to do scope to scope index squared. Understand what I mean? Stop. Yeah, so see, now this is kind of what we fucking want. So under 1,000. So once we go from here to here, it's much more expensive. Yes. Okay, so this is total weight. And then this is also going to take this dictionary. Range. Scope to weight. Okay, so let's move this here. So So this is going to be for scope min, scope max. So we can unpack that tuple in line. Weight in scope to weight items. This is a tuple int to another int. If value is scope min value scope max for value in values. Meh. I don't think this is gonna work. What's the issue? Local value reference before assignment. You can't do it out here, you have to do it in there. Fuck! Now it's gonna be full of nuns. Oh, this is not going to hit this file. Shit. So that means we're ditching that file. Excuse me. Sorry. Okay, so we just have to filter out the nones. So this is going to be return sum of filter weights lambda weight is not none. Output. Wait, so if... Right. 0 should be very special. But I think I can get to that in a second. So maybe do it like that. Yep. So if 0, if value equals 0, else Zero is the most prized peach. Okay. This isn't the most efficient function, I don't think, but it works. Okay, so, alright, so we're big chillin'. So let's just run through this whole list of options. You know what I'm saying? You know what I mean? You feel me? You know what I'm saying? Fuck. We know who we want to win. Who we want to win in each of these. Spending a minute alone. Alright. So, total weight of values. So, print values, weight. Let's do weight first. Weight values. Here we go. Okay. So that's wrong. Why does that have 0? Pressure me back. Wish I could get past that. Alright. Ah! Huh? Is this the problem? Alright, we need to do this. These need to be both inclusive. So he still wins. So I just need to I need to define that as an actual thing in the range. So what did we say? Sorry. I need a mute button. Okay, so let's make these smaller. So 0 to 1000 is very quiet. 1001 to 2000 is medium quiet. And then 2001 to 3000 is loud. I guess. So this is saying that 2 mediums and a quiet is better than 3 mediums. So I think I have to just define the weights manually, unfortunately. So this is going to be another tuple. So this is going to have the weight in here as well. So let's do this. So this is weight 1. Actually, these are both mediums. Wait a sec, puppy. Yeah, so this is, okay, so this is right. So this is saying, where am I getting this 1300 number from? This is 2 quiets and this is 2 mediums and a quiet. This is 3 mediums. Which is what I want. I guess what we're actually, sorry, so I'm going to delete that. Okay, let's switch this up. We're trying to get to 6,000. So 6,000 could give us... No, we're trying to get to 5,000. So 5,000 could be 1,000, 1,000, 2,000. 2 quiets and a medium. This is 4,000, 1,000, 0, and then this is 2 mediums. No, so 3,000. We're trying to get to 5,000. Yikes. So yep, this one's better because it doesn't go into that third range. But this doesn't make sense. Oh, because that number is out of scope. So this is 3,000, 1,000. So we're trying to get 5,000. $1,500, so 2,500. Alright, so this is it. This is the idea. So we have... Oh, he's back. Tech is back. What's going on, bro? My dog is being an ass hat. Damn. Your dog... Dude, fuck your dog. What'd he do? Did he eat your computer? Well, he's my wife's dog. Right, exactly. Yes. Yes. What happened? What's going on, bro? What the fuck is going on? It's good to talk to you. I saw that computer. Whoo! Looking good. Yeah, yes. That's the way she goes, dude. Dogs be dogging. They always get so much more aggressive when you have them on leash, too, for some reason. Makes no noise. Makes some noise. Makes a lot of noise. Yeah, I don't know what a leash is. Right. Oh, cool. How many dogs do you have? Sounds like you have more than one on them when they have to go to the vet. Okay, so... No way you have 11 dogs, bro. No way. That's a lot of dogs. Damn. Homie's got 11 dogs. I love it. You got 11 dogs, dude. $11 fucking dogs. That's so sick. Dude, you're really out. You're living that beautiful farm life. Susie, Ellie. Wow. That rules. Do they live in the house, or do they live in the yard, or do they live in some combination of both? How do you have... Dude, that's such that is such a crazy number of dogs. Housing them is or like the whole operation, feeding, housing. I bet it's a whole production. I love it. I love it. Come and go when they want. I love it. Okay, so what I'm doing here is trying to come up with an equation that encodes the behavior that I want in the fans. So I want each of the fans to be spinning as slowly as possible, and three fans spinning slowly is better than a single fan spinning fast. Two fans spinning medium is better than one fan spinning fast. So trying to encode that behavior as code, so that way it can run in the microcontroller. And I think I got something, and I did a bunch of weird. I have the ability to draw on the screen now, which is funny. But that's where I'm at. I've had a pretty good stream so far in terms of like figuring stuff out. Not bad for 2 hours. So that's where I'm at. Keeps the neighborhood and extended family nice. Don't like people much. What do you mean? Well, yeah, keeps the nice. You gotta give me a little. It's probably a long, beautiful story about your history with these animals, but you gotta give me a little bit. So is it like, let's get 11 at once, or let's get a couple and then his brother, and then they have a litter, and now you got 7, and then da 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 da. You gotta give me a little bit. You don't have to tell me the whole thing if you don't want, but that's very interesting. I've never met anyone with 11 dogs. I've only met people with like 2 dogs, 2 or 3 dogs. 11 dogs, that's awesome. Okay, yeah, so if it reaches temperature X, it'll turn on Y fans at Z speed. So we're going to use PID, which is a control method. PID is a way of, it's how cruise control works. So if you are really below, you set a target, and then if you're below your target, it puts a lot of energy into the system to get up to that target. And then once you reach your target, it only puts a little bit in to like maintain. So we're going to use PID to do the control, but in terms of what the controller is actually modifying, that's going to be ranges within this. That's going to be like this algorithm. So yeah, the idea is to make it more expensive for it to turn the fans on, or the cost function is all about noise. So it'll prioritize putting as little noise. Yeah, I read. That's so funny. I read that article. Yeah. PID control Python. Yeah, I actually got a whole controller going right here. I found there's a PyP package called Simple PID, which I very easily adapted to MicroPython, and that's working. So I got the PID controller done, but now I'm trying to figure out what the right. So the PID controller outputs it outputs a value, outputs a power value. So translating that power value into fan motion is what I'm working on now. So yeah, and I think I got an approach that I really like. So I'm going to go through and start to work it into the actual fan controller code. And first, I think I'm going to, Yeah, first I'm going to take a quick break. Get a little bit more ice for my iced coffee. BRB! All right. Let's see what we got. Turn this off. Oh yeah, we got notes. Expand it. You see a puppy running into the house that stopped and got it. That's Rusty. Jesus! And the other day, waiting for a truck, this border collie wife. That's Bandit. He's my best friend. He follows me over and me all the time. He's the one I try to pick. Nice. Pocket cheese. Ooh. I have to Google Chi Weenie. Oh yeah. Oh yeah. Drugs of some sort. Nice, dude. Wow. So it's a very altruistic. You have an altruistic heart. That's very nice. They're all like rescues. I love that. Nice. Like first-hand rescues. That's awesome. Dude, my folks have 2 dogs. My mom's always had dogs. I've never had a dog though. Definitely, I grew up with a couple of dogs, but not had one since moving out. All right, this is a little too tight now that I'm standing. All right, let me move this. Zoom this. There we go. Ear. Ah! Guinea pig is a rescue too. Nice. Oh fuck, that's not in focus. How did I just bump that? Oh, that's the aperture. Alright, there we go. Ugh, why is it out of focus? Guinea pig is a rescue too. Can't do that, so I'll take her. Nice. I hate when people get pets they can't handle. Alright, framed up. Alright, now we get back to it. Nice, dude. Pet City, I love it. You ever, always wanted an aquarium. Something I was thinking about doing for this channel was, or for the stream, like a fun on-stream project would be make an aquarium for a clam. So, like, do... Worst place I've ever seen for stray animals. Huh. Yeah. Sounds like it. I mean, if you're seeing them all over the place. I always talk to my girl of, like, if I ever saw like, it'd be fun to, like, pick a dog up off the street or something. But, yeah, never actually seen it, amazingly. Yeah, so I was thinking about it could be a fun stream project to do, like a super sensor heavy aquarium for a bivalve, for like a clam, because it would be like good for time lapse stuff, good for sensors and control because you want to keep balance and stuff, and that could be fun. And it would be cool to have a little aquarium going in the crib because you don't need any space if the animal doesn't move. Alright, so let's get back to this. So we have the function that is going to weigh and then it's going to weigh liveaquaria.com. Ooh, something crazy like that. Pulling up research. Oh, this is Chrome. Cut. Let's see what we got. Wow. This is way fucking cooler than I thought it was going to be. Or than I was thinking. I was thinking, like, literally I could just walk down to the water and, like, dig a quahog. I was thinking for mine, because I can just go find one of these in like an hour. I'm like near the water. Something like this. Like this little freak. That'd be fun. I don't know. But yours would probably be more interesting. Yeah, I figured out how to do draw on the screen. So it's actually an MS Paint window that I have chroma keyed. So the blue background, I just chroma keyed that in OBS. So I can draw, I can just use paint like I would, and then I can draw on the screen. It's obviously a prototype. Like it's not a very robust solution at all. But I wanted to see if this is something I would like to do before investing time in like figuring out a better solution. And I think, yeah, it was definitely cool to work out this stuff. And like, you know, my handwriting's not that great, etc. But could be improved if I made better tooling. Yeah, it worked, right? Yeah. So what's your Tech? What's your question, bro? Hit me. I love coding questions. All right. WTF is a JSON. It is Java Standard Object Notation. It's a way of relevant to the month. Yeah. So JSON it's a text file. So it's a text file. It's literally a text file. So I have a ton of JSONs for the Faces project because we're using them as a intermediate layer. So I have, here's a JSON file. So it's literally code, reformat code. So this is a JSON file from that Faces project. So it's like a way of saving data from in memory, like a local variable, to like something on disk that you can then go reload. So all it is a mapping between key value pairs. So the key in this case is image hash, and the value is this number. Image path, and then the path is this string. So JSON is a way of saving a variable from in memory, so like instantiated in your program, and then onto disk. So onto disk is like a file that you can like email. Like I could email you a JSON, can't really email you a running program because it's in memory on my machine. So it's a way of Yeah, so it was originally designed for Java, but it's all over the place, right? It's, just pick a language and it'll have a JSON way to interface with JSON because it's just text files. So just like in the same way that you can open like a text file, like a .txt or whatever in many languages, JSON is just text. It's just text. So any language that can work with text files can probably work with JSON, and it's a way of like getting like being able to interact between multiple languages. Like so I can write, so say I'm an engineer and there's a front end system like a website and a back end system that's like say I have the front end of my website's written in JavaScript, and then the back end of my website is written in Python. So say I do a web store, so orders would be placed on the front end, and like an order could result in like a JSON file that then could get sent to the back end. The Python program would then like open up that JSON and work on it, but it originated in the JavaScript. So the Java in JSON doesn't really have anything to do with the language. There are other things like JSON. Some of them are language specific. The JSON version of Pickle, or the JSON version of Python is called Pickle. But Pickle isn't a text file. Pickle is a binary file, so you can do a little bit more with it, but it also means you can't like open it in a text editor. You need to open it in a binary editor. So there's a bunch of other different things, but it's a JSON's just a text file, just like any text file you've ever opened in your life. Like a lot of files are like that. So yeah, JSON. All right, so let's get back into this shit. All right, so what I'm gonna do, I don't know. Okay, so I want this to be in this file. So okay, so I'm just gonna copy this over. I think I'm gonna not worry about structure now and just get to that later, like how to lay this out. All right, so let's start to actually implement this. All right, so I think what I'm actually gonna do is back up a little bit. So now, so what we want to do, right. All right, so this mapping. So power goes from 0 to 1. So we want it to go from the minimum speed we can spin a fan to the max speed of the fan. So max duty. I'm gonna move this over here, go back over to here. Okay, so Raspberry Pi Pico PWM. So is that number U16 max value? Can I hide this? Sponsored shortcuts recommended by Pocket. Nice. Why is it not doing the max here? Alright. We're just gonna trust that. So max duty is this. So we need to translate power from the minimum possible duty to keep the fan spinning, which I think we can bring even lower, but I'm gonna have to get this. I'm gonna have to do some more experimentation with this. Determined experimentally. Per docs. Raspberry Pi Pico docs. Okay. So Python, Arduino. Wait, I wonder if micro Python map function. Map function. Do your equivalent? Is there an equivalent? In this page, you can define your own function. Not that I'm aware of. Left off to the user's code. I think just think. Unlike Arduino, doesn't even have to convert do. I do. Lerp would be useful. Linear interpolation. We'll return an integer. We'll return an integer between outmin and outmax. Yeah, this is what I want. Linear interpolate. This is a float. This is a float. This is an int. This is an int. And we're going to return an int. Okay, so I'm gonna say reply with quote. Is there a permalink button? Works like Arduino's map. Thanks to this post for the port value to scale. Min minimum output, maximum output. Scale the value in the space between out min and out max. Alrighty. So we want to take All right, so we want to go from let's do a couple more constants. Power min, power max equals 0 to 1. I'm almost out of coffee. Shit! Alright, so the target counts equals what was that function? Linear interpolate between, so linear interpolate of new power from in max, so power min, in min. Let's just do this. X equals new power in min, power min, in max, power max. And so out, this is where it gets interesting, out min is going to be slowest possible speed duty out max max duty. Okay. Coffee sucks anyways. Yeah, I'm gonna do tea next. That's a good call. Alright, so out, okay, so this is times the length of self.pwm controllers. Okay. So this is the number of counts. Ugh, this is disgusting. This function sucks. Yeah! Be a waste of money. I don't make enough money to be throwing away tea, bro. That's funny. Alright, so this is gross. This whole thing is gross. I don't want to do this as a class. I want to do this functionally, but we're just going to rock with this for now. So we need to figure out, the next thing we need to do is come up with a What's your favorite kind of tea? What's your favorite kind of tea? Wait, let me show you. Let me show off. I got this shit. Woo! It's a loose leaf. Do you like loose leaf tech? Oh, loose leaf Earl Grey. Gets you right. That thing was expensive though. But English breakfast? Yeah, my fiance loves English breakfast. English breakfast as well. Jesus. All right. So once we have target counts, we need to do the thing I tweeted about, which is a process called integer partitioning. So that's not loose leaf to use in college. I like it. I like I don't know. I'm a bit of a. I like the aesthetic of it, and I like not having to like. You don't have any. You have like much less packaging, which is nice. Yeah, I like loose leaf a lot. I prefer loose leaf. I think it's a little bit more money, but it's also cheaper and I don't know. Tea is so cheap, anyways. I guess I don't know. Whatever. Whatever. Ooh, Jesus, that sounds fucking good. Damn, that sounds good. Alright, so this step is going to be partitions. So this is going to be so what do we want to call this? Candidate speeds. This is going to be a list of lists of ints. Well, sequence. This thing that sucks about this is we have to consume. That's the other thing I haven't figured out yet. Is the fans don't need to be infinitely adjustable. That'll make this other problem easier to solve. So say we do like each fan has it theoretically it has what's the difference between these two numbers? It has like 1,500 different speeds. 40, 65, 6, 5, 025 minus boom 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 boom. Yeah, 2,500. It's got a lot of speeds. I don't think that being able to individually set it to any of those in between is necessary, especially if it limits computational if it's gonna make things slow. So I'm thinking about doing this next step with like a fixed number of speeds per fan. Call it 100 speeds per fan. Call it whatever. So, but all we know. Okay, so that's what we're gonna get into next. So this is gonna be candidate speeds, and this is gonna be we can stub out this function right now. So it's going to be candidate speeds. You really admire me. Why? Candidate speed. So that's going to be right. Well, okay. This is the thing. The thing is, right. The thing is that I have. It's like, yeah. They're loud as shit. So I want them to be quiet. I could have, yeah. Normally that's better, but the fans aren't gonna get here until the 15th. So I have time. And then 2, I really want this to be as quiet as possible because this thing is like my roommate. I don't have, like, I can't like put this in another room in my house. I have like the one room. So it's got to be quiet. So that's the idea. But it's got to be quiet. It's got to be able to go up as well. But yeah, well, I don't know. Might as well get fancy with it. I have a feeling that I said it on an earlier stream, but there's sometimes when you work on projects like this that they live for a long time. Like sometimes you work on a tool and it becomes irrelevant really quickly because what's a good example? Something I've built. So it's like, say you build like a shelf, and you build a shelf out of like sawhorses or something, or you build a table out of like sawhorses because you're gonna buy a real table. Yeah. No. Yeah, I got time. But I do, it is often the better engineers are usually the lazier ones, like the people that are able to identify the corners that are okay to be cut. But yeah, this is also a fun thing to be able to work on this. All right, so off on a tangent. It might be tea time soon. It might be tea. Tech, do you have any English breakfast, or are you? Yeah, it's kind of late in the day for some. I'm definitely gonna stay up wicked late working on this, but so candidate speeds. So we're gonna do, I don't even know what I'm gonna call this thing, so I'm gonna stub it out though. So this is gonna be I tell my boss that, yeah. It's true. And I'm copying a lot of this stuff from stuff I see online, but this kind of thing I gotta do myself. All right, so this is going to be combinations. Ooh, very nice. To some. Ooh, strawberry kefir water. What does that taste like? Tastes like strawberries? Googling. Strawberry. Oh, nice. Was it yogurt? Yeah, nice. Love that, love that. All right, so combinations to sum. So this is going to be so this is going to be potential values. So this is going to be, or like, yeah. Nice. So this is going to be a list, no, sequence of int, and then value is going to be int, and then we're going to do, you're looking at probiotic with water with, oh, so is it like kombucha? Is it, if I've had kombucha, I've had kombucha, I've never had kefir water. Target value, and this is okay, cool. Same idea though, nice. Oh, I'll be right back. Alright, bang. Thought I heard somebody knocking. Alright, so potential values. So then target value, so target length, number of values that can be added together to make target value. This is going to be a list. What am I talking about? A list of, let's just call it list of tuple tuples that add up to target value. Okay, so what did I just call that function? Combinations to sum. So potential values so range between start or so let's just do all values for now. But this is where got list tuple into what? Okay, so potential values, length, target length is the length of self.pdom controllers. Target value is target counts. Okay, so then we're gonna have this big ass thing. Got list. Okay, so right, that's what it was. Okay, so this is tuple. All right, so rank. Next we need to do rank. Scope to weight. So we have for speeds in candidate speeds, we want to add the weight on speeds with weight. So this is going to be a tuple. Total weight. Values is speeds. Scope to weight is scope to weight. So that's one end of the tuple. The other end of the tuple is the actual speeds. And then we want, so then we have, then we should sort this. We should just get so it's the minimum weight. Quietest. equals min. So it's going to be speeds to wait, and the key is going to be a lambda function that takes the speed, wait, and speed. So this is wait and speeds. This is wait and speeds. So it's just we're just gonna pop off that first value. So it's gonna be wait and speeds 0. And then we're gonna take quietest speed. And we're going to take the first value. So that's the actual speeds. That's what we return. Quietest speeds. So that's it. Apply linters. Okay. Right. So yeah, this whole thing can be a module function that we can test, which is how this is breaking down. So that's what I said at the beginning of the stream, was that I don't love doing this object oriented. I'm just doing it because I think it's the fastest for me to develop. So we're just gonna move this to a function. It's gonna maintain, yeah, it's gonna just take all of the changing stuff as arguments, and then the, yep. Yeah, okay, so let's do that. Actually, I want to commit this. Is there anything left that's useful in here? Weight ranges. Nope. So this guy can get deleted. Okay. This function I need to implement. All right. But this is basically it. So then we'll take quietest speeds. So for PWM pin speed in zip self dot PWM controllers and quietest speeds, we'll do PWM pin dot, aw, come on, what's the function called? Duty U16. That's it. And then I guess we'll return quietest speeds. Okay, let's try and commit this. Missing integer partition function, but weights function added. When are you making your How to Python series on YouTube? Never. I'm a bad. That's a. You know what I'm saying? Who knows, brother? Who knows? When are you making How to Python series? I don't know. I don't know if I'm the guy you want to learn introductory anything to. I'm pretty bad at actually that's not true. It would take me so long to do. And I don't know if that'd be hard. How to Python. I think the best way to learn Python, in my opinion, is pick something you want to do and try to do it. Like, Python is such a generalist language that you can run it on basically any computer. You can run it, like it can do so much. Like it's a web server, it's a text editor, it's a calculator, it's a fan controller, it's a camera, it's a microphone, it's a keyboard, it's a shell script. It can do. It's basically like a user interface for anything you would want to be able to do on a computer. The best thing to do is pick something you'd like to do and then decide you're going to do it with Python. And then just try. Just like start Googling of like, okay, so say you want to make like a thing to automatically order you a pizza. It's like, okay, Domino's Pizza API, Domino's Pizza API Python, like, and then just go from there, like, and just start Googling from there. So it'd be, I think maybe a goal with these streams is to teach programming, teach all this other stuff in a very practical way, like a very experimental, like way more practice, almost no theory kind of way. Yeah. So next week, I'm gonna go make a tea and turn the lights on in here, because I have to do some surgery on this thing. Yeah. Here's an object. Can you see if it can move? All right. Burb. Okay. Woo! Dude, 10-minute break. It takes like 10 minutes up and down to like make tea. You know what I'm saying? Which is a long time on stream. So maybe I should figure out. I don't know. Good to take breaks though. I'm going for 3 hours. Alright, so. Oh, cool. K-cup tea. Nice. Nice. You're not a coffee drinker though, right? Probably the wife, coffee drinker. Nice. Probably much faster than this. Alright, so I'm gonna roll back these changes. Delete all of that. Delete button didn't work. Let me know how it is. I do not have a Keurig. Trying to think of a Python project, but I can't think of anything. You like PC gaming? You could do like something that could run in the background and monitor your CPU temperature, something like that, if you're trying to optimize something there. Cooler A manager equals fan controller dot cooler manager and numbers Let's keep trying to commit this. Unused variable. Okay, so what I'm doing now is I'm going through and I'm saving my work, basically. Yep. Saving it to Git. And these pylint statements, so I'm using a linter, which is a way of having a machine check your code quality. And so this is a linter I use on a lot of projects. Yeah, so that way my code is consistent across projects, easier to read, easier to maintain, all that good stuff. All right, so next we got the PID. So this is not my code. Missing function docstring. Line 11. Truncate a value within some given limits. So yep, so we kind of got to do a little work on this thing. No big deal. So this is a union. Union between a float or an int. These are all forward references. And then this is a tuple of two of those. And it's going to return a single value . Alright, value to truncate. Too many instance attributes. Line 25, so it's probably this. Length disable equals too many instance attributes. Oh, that's it? Nah, it's gonna be upset about the assigning result of a function call where the function call has no return. What? Current time. Let it last a little longer. Alright. Platform. Oh, agnostic was the word that I was thinking of. I couldn't think of the word agnostic the other day. Fuck. There it is. Platform agnostic. Yep. Okay, let's work through my problems first. 61. Okay, so alright, yeah, so I guess yeah, we gotta do this. I really just think this is probably gonna be a list. List of a list of numbers. List of numbers. Let's just say that until we have a reason not to. Oh yeah, tea time, baby. Damn, that kind of tastes weird. I'd love to have to make some sort of GUI or something. Python has a bunch of GUI stuff you can do. This is built right into the language, so it lets you draw stuff. There's also Pygame. People make games in Pygame, but it's really good for UIs. I'm actually switching back. This should be tuples. There's no reason it needs to be lists. Tuples are a little bit faster. Actually, I don't know. Maybe that's me being superstitious. Let's hit the fucking research. Tuple versus list speed. Python. Tuples tend to perform better than lists in almost every category. I'll take it, bruh. Yeah, PSUtil. PSUtil is amazing. PSUtil is really cool. It also works across platform. You could do like okay. You could write a Python piece of Python that could like change your case LEDs depending on CPU utilization or something like that. That could be cool. That could be cool. Yeah. That could be sick. That could be sick. You could use... Do you have you ever worked with an Arduino? You could use an Arduino. Let's do a fucking drawing, bruh. I'm saving this. And it lasts a little longer. Alright. Draw, go. You could do... Oh, wait, I did the wrong color. Ah! I've got to pack an Arduino Uno and pack 5 nanos. Bro, we got it. This is what you're doing. Okay, there we go. With the right color. Yeah, bought a pack of 5 nanos. You could do... This is what I'm thinking. You could have... Yeah, you don't need to... Definitely don't spend any money. There's plenty of amazing free... PyCharm might be too crazy to start with. PyCharm is like really big. I wonder if there's a more beginner Python editor. I'm sure Visual Studio Code 2LM right now, like LOL. All right, so what you're gonna do? You're gonna have God damn. So you're gonna have your Python program. It's going to talk over USB to an Arduino. And then the Arduino is going to talk to over probably fast LED to the LED strips. So it's going to you're going to have a USB cable inside your computer that's connected to the Arduino inside of the computer, and this is going to send CPU, temp, etc to the Arduino. So you're going to have to do both Arduino programming and Python programming, because you can't write to the LEDs. Actually, are the LEDs connected to the motherboard? Because if they are, I bet you some guy has written a Python library to control those LEDs from within Python. Alright, I gotta get back to this. There's LEDs on the motherboard, on the RAM, and the rest are on the ARGB header on the motherboard. Yes, sir, Tim. I'll figure out some type of direction. No worries, bro. Yeah, that sounds sick. No worries, bro. You could do that. I've written a Twitch bot before. There is tons of... There's many ways to have Python interface with Twitch. That would be funny, dude. If you did a bot, that would be so funny. I would love that. Finish and sell a Python. Okay, enjoy. Oh, don't need to do it there. Okay, so what we're doing here, so this library, or this function, class, what you want to call it, I got from GitHub. It's an implementation of a PID controller. In my testing, it worked great. But there's no typing. So I'm going through and adding typing, which is kind of a study of the library. See how it works. And because we're doing MicroPython, we have to have everything defined as forward references, because forward references, which are these quoted type annotations, forward references are allowed in MicroPython. Functions using return type. Where does proportional come from? Self.proportional equals 0. Variable has type int and compatible types in assignment. So this should be 0.0. Expression has type float. Variable has type none. What? Yeah. So this is an optional. These are all optional floats. Return a string. Chat. What's going on? It's Saturday night. I'm doing code. components. So this is a tuple. You are float. You are float. You are probably float. Tuple of float, float, float. Same thing as before. So this is entirely the same type as that above function. Bool. Optional. Bool. Output limits. I think I don't. Some of these functions I'm never going to use. Like we're never going to change some of these things during a run. So I'll probably end up paring this down a bit. In the end, but for now I'm not going to. Actually, in the end, I might not either, to be honest. Because if it fits in the MicroPython, yep. If it fits in MicroPython, then output limits. Same thing here. So if it fits on the chip, then I don't need to delete any of this. Awesome. All right, so we're committed. So now what? Now what? So we either, so what I want to do is make a nice visual to try to see how this weighting algorithm is working. So I want it to look like this. Nope. Fuck. So 2 axes. So we'll have yikes. So we'll have input power 0 to 1, and then we'll have fan or ADC or PWM duty, and that'll be from like the 40K to 60K. So this will be a line, and I would like to plot like the makeup of it's hard because I can't really do that many colors. The like powers of the individual fans along the way to show like that behavior. Yeah, this is probably as bad as it gets for a drawing of what I want to do. Blah, blah, blah. Okay. So that's where I'm headed. But I need this combinations function to get there. Oh, wait, this is a list. Let's redo that. So that's where I'm headed. And I think it's about time to It's about time to work on this combinations function. So, okay, this is a good intermediate point. So, what we need to do with this function is, for a given target value, come up with every possible numerical combination that will add to that value. So this is called integer partitioning, is a thing that I learned just last night. Integer partitioning. Partition. Research. Integer partitioning. So in this example, this person's trying to get to 4. These are all the ways you can get to 4 with 1 to 4. So for us, we need to see every possible fan speed that can get us to that target speed, to that target count. And then we need to, of those target counts, pick the one that is the quietest. We already have the function written to do that conversion, but we don't have the function that is going to give us the target. So all right, so we move this over here. I have a couple of, well, just like everything else in this chat, or in this project, I found a couple of implementations. Yeah. Found a couple of implementations of these on the web. I'm pasting them into my research browser. Subset sum problem is a decision problem in computer science. So the thing is that I want I want more parameters than these two implementations. So numbers, target, partial. So I want to also be able to provide, so this gives you the candidate numbers that you can input, gives you the target number you want, and that's what you can input. So, but I really want I want to control this length too. I only care about solutions that are, you know, less than the number of, less than the a certain amount of number, or the number. Right, so if I have 3 fans, I only I care about combinations of numbers that are 3 or less. So I actually haven't run these yet. So I'm going to try this one, because this one looks good. So I think I want to do this. I want to test this thing in a test suite. So new file, test fan controller. So from Tesla Cooler, import fan controller. So, oops, wrong window. Sorry, guys. All right. So, test def test subset sum. Fan controller dot subset sum. So numbers. So 1, 2, 3, 4, 5. Target is 10. So I'm gonna debug this test. Test failed. Attribute not found. Machine. Okay, so. I think I need to do forward references for this. Or maybe I need to do this. Mark directory as sources root. Mark directory as sources root. Meh, this sucks. I kind of don't want to fuck with that on stream. It's the thing, like getting at these MicroPython things underneath the hood suck. Or like it's like I want to be able to run this code all over the place, but I need references from the MicroPython specific stuff. So what I'm going to do is just make a file that is clean of MicroPython stuff. Just call it fan speed control. Refactor, rename, test fan speed control, and we'll move both of those. We'll move this guy, refactor, move to fan speed control, and then we'll move linear interpolate, and we'll move subset sum, we'll move combination system. Refactor. Cool. linters. So from fan speed control. All right, now this should work, right? Nice. Result is a generator, I think. Oh no, I don't return anything. What? Huh? What? So this. Okay, so this is bad. This one sucks. So this missed 5 and 5. Alright, so maybe this is not the one we want. Okay, so it would suck to have to filter that out. Right? That would be annoying to have to like, so say we find one of these and we just have to drop a bunch of it. So what's I here? I think we want specifically, I think we specifically want subset sum. Subset sum Python. So yeah, we need subset sum. That way we can reduce the compute space a lot, because we can just pick, like, here are the number of speeds. Here are the number of speeds we can input. Python subset sum for a given length of elements. Alright, is subset sum. Variables combination, yeah. Well, this thing would work. I think I just want to do this, because then I could just write it myself. Something like this. Alright, literally return potential values. So oops, forgot to switch over to code. Fuck. Okay, so okay, we can get cute here. So we can get cute here. Yo, he's back. Tech, what's going on, bro? Yeah. I'm thinking about, the thing is this, nice. Does that work? Nice, you already got it, bro. It's quick as fuck. I love it. Let's go, dude. That's easy peasy. This is why Python rocks. Takes 10 minutes. I love it, dude. Yeah. I've thought about it for 1 minute, and I think that I'm just going to do a naive approach first. If the naive approach is not performant enough, then I'll look for a cuter thing. Yeah, head take off for a few real quick family. Hey, do it, bro. Thanks for hanging out today. This was really fun. I love your presence in all these streams, my guy. I gotta figure out how to mod you. I don't know how to do that. I think you are definitely the most active user in my chat, so I have to figure out how to mod you. I don't know where I do that from though, but I'll figure it out. Yeah, enjoy dinner. Say hello. Say hello to all the dogs. Have a good one, bro. Alright, so... what does that do? Okay, so we want to take let's just do a naive approach. So the possible inputs are for blank in target length, in range target length. So this is values, potential values. Unfortunately, we need every combination as well of potential values. This is fucked. I don't really know how to do this. Or, like a good way to do this. So we want to have, of these potential values, every combination of them that add to the number. But duplicates are also okay. So it doesn't have to be a unique combination. Alright, I'm going back to fucking Stack Overflow. Unless MicroPython... Ah! What did I do? Okay. Unless MicroPython combinations... Right. Yeah, this algorithm can get real inefficient real quick is the problem. Python subset sum problem. Shit. Okay, so we want to get every combination of a list of numbers that add to a specific number. You would think that that would be an easy thing to do, but it's not. With constraints and multiple inputs. Okay, so maybe we do need to just I'm going to just keep trying to implement this naively. So we need every 3 with iter tools. Okay. combo in if some combo equals target value. That's it. The most naive possible implementation. So let's take this. Potential values, target length, target value. Target length is 3. Zero needs to be in here. But we can have numbers that are the same. Fucker! Iter tools. Come on, man. Iter tools, combinations. What's with replacements? Individual elements to be repeated more than once. That's what I need. Five and 5. Okay, so. Oh, hell yeah, there he is. So. This thing is computationally fucked. So. Oh, nice. Mom is making us dinner. Let's go. Free food. You got it done as perfect in the first try. No, I'm gonna have something that is super inefficient. I think. Yeah. Let's pull up the system monitor for my... Yeah. Yeah. So if we have, okay, so let's do 100 speed options for 3 places. Okay, that doesn't make any sense. There's no combination of 3 numbers that equals 2000. From 0 to 100. Ew. So we want to go 0 to 100, step 0 to 1000, step 100, or step 10. So that's 100 values. Oh, okay, that was pretty quick. All right, so that's 100 values. I think, yeah, that's 100 values. Okay. So, how long is this thing? 883 combinations. Yeah, that's like about right. So we also, the thing is, we also have to consider the 0 case. So yeah, text. So my approach here is just try a naive thing to see if I can figure this out in principle. And then probably after that try to optimize it, try to make it better, but just to see if this works. All right, so let's do a closure. At sublength. Mutual exchange up front iterable. So this is going to be at sublength for sublength in range target length. So this is going to be sublength plus 1 plus 1. That's wrong. You might have to do you might have to do something like this, like pym pip install xyz. The pi-m pip. What's the error? Yeah, try, what happens if you just run this? Or then... Yeah, it did. Yeah, Windows is weird. Of course. Where is your buy me a coffee link? It's coming. It's coming. I haven't figured any of that stuff out yet. I still don't know if I like the streaming thing. Actually, that's not true. I like it. Yeah, I'll do it. I'll figure it out. All right, next time I go live, I'll have a dono link. Let's do that. Thank you, bro. All right, so okay, so this is working. So I need to zero pad this. For the sub length, I need to pad this with zeros. Zero pad tuple Python. zfill. I don't want to use zfill. So this needs to be this needs to be this length every time, but this is going to be different here. Because those 0 values are going to be really valuable. So what is the way to do this? Okay, so what I'm trying to do is figure out how to add zeros to this tuple, to these tuples. So for if length of tuple is less than target length, okay, so for zeros, oops. So we want to do pad equals tuple of 0 for range target length See, we want to do just add those to the end and then truncate. I guess. Okay, so that's a deterministic thing. All right. Yikes, wrong. Oh, I'm missing a parenthesis. For sure, I'm missing a parenthesis. Yep, 2 plus pad. Mm-hmm. Alright, so see, another thing we don't want is this, because here, this is going to score the same. So we only want one of these. So this thing, this is all sums, all combination, all valid. So we want unique valid. So we'll do sorted valid equals sorted combo for combos in all valid. And then we're going to take the set of that, set of sorted valid, So we got, oh fuck. Yep. So yeah. We'll just cast this to a list for testing. All valid. All valid. 0 sorted. None type is not iterable. Combo and all valid. Am I consuming one of these twice? I could be consuming one of these twice, which is why this is fucking up. It's possible. Even though I should only... Let's try this. All valid. So sorted, all valid, 0. Holy shit. What the fuck is going on there? Where are these nuns coming from? Oh. I was being dumb, boys. Fuck. That's embarrassing. Alright, so we got sorted valid. We can convert this back to a tuple. Alright, I think we should be able to run this. Alright, nice. Okay, so far the only library functions that I'm using are from iterable and combinations with replacement, which I should technically be able to go read. Psych, can't do that. But this is it. So this is a if the input tuple is less than the target length, add zeros to the tuple until it reaches the length. Tuple to potentially tuple added to length. I'm just gonna do this. Yikes. So I wonder how fast the Pi is going to be at doing this. You know? Probably pretty quick, hopefully, man. I mean, this computer's pretty fast is the problem. And this has got to move back down to a Raspberry Pi Pico, which is not fast. Yeah, only one way to find out. Yeah. The problem is I have the thing installed in the server right now. I wanted to leave it. Didn't really want to fuck up my whole setup until the new fans got here. But I might do that tomorrow or tonight or something. Get the fan out. Get the thing out because I'm not using the card. Okay, so we have this algorithm. So now what we can do is rank it. I'm just gonna save my work. How do you naive implementation of, alright, so this is going to be like unused variable, missing docstring, so missing module docstring. Code for controlling fan speed. CD, more docs. Consider using generator. What? Okay. Thanks, pilot. All right. So that's that. I think I need to go make dinner. It's been a 5-hour stream. I might make dinner and then hop back on. I'm still in the flow with this, and I'm still not where I want to be. Maybe I'll keep rocking though. You're going to make it like I did. Nice. Yeah, unfortunately, that is not an option. I wish. It's just me, dog. Alright. Alright, so let me try, yeah, go make some food. Good call. Alright, everybody. It's been real. I think I'll hop on later. I think I'll hop on later. Or maybe I won't. I'm really feeling good today, though. And I've got a busy day tomorrow, so I'm not going to be able to get back into this. I don't know. We'll see. I'll tweet. Yeah. Hey, thanks, Tack Dude, for hanging out. This was so much fun. Enjoy the rest of your night. Hope you have a sick-ass dinner. Enjoy, my bro. I'll be here if you do. Alright, cool. I'll see you later then, maybe. Peace, brother. Oh, yes. Yes. Part motherfucking 2 of the day. You know what I'm saying? Oh, didn't you already stream? Oh, didn't you already go live today? Oh, it's again, bro. It's round 2, baby. Yes. We back for round 2, motherfucker. We back. We back. We back. Let me just make everything sound good. You're just drunk. Yup. It's time, baby. All right, hey. Where did my freaking audio go? My freaking music. That's a new one. Is this bitch dead? Alright, let's reboot it. Rebooting tunes. Boing. Boing. That's a freaking new one. Exit page. Alright, well, dogs, we back. We back in the motherfucking mix. It's a Saturday. What else am I gonna do? Nothing. You know what I'm saying? Zero. This is what I'm doing. I'm programming. That was so weird that's song bugged it out. Oh, where did this playlist go, bro? No, my modification. Oh no, we're chilling. Save. Yes. All right, dudes. We kicking it off with some motherfucking Bizzarino. Yup. All right, dudes. Yup. Firefox, get out of there. I think the stream looks boring. Which is funny. Because it is boring, in fact. So maybe I should come up with a cooler theme for my editor. Or something like that. To make it look cooler. Or I should do something crazy with like, oh fuck. With like CV or something and like make my eyes different or something. Alright. Yes. We got the tunes back for this hour though. Alright, so what are we doing? So what we're gonna do is we're gonna visualize this. Alright, so it's time to move this into its own function in the other module. Alright, so that should be real quiet. The music should be very quiet. I'll go down a little bit more. Minus 6 dB. Alrighty. Alright, so quietest drive values. So this is kind of the whole point of this file. Ooh. I'm not talking. I'm be talking more. All right, this is what I'm thinking. So this function is going to take a power and convert it into drive values. I think this is going to be the main entry point for all this stuff. What I'm imagining is just the visualization function sweeping 0 to 1 here. So this is what's gonna be the most parameterized, or the most parameters. So this is gonna have like power min, power max. Yep. So we're gonna want to do duty min. Well, all right, we know the output's going to be a tuple of ints. Yep. Okay, so yep. So this is num. And this is int. It's gonna go here. That's gonna go here. So if we pass in the weights, we don't really need to pass in. Weights can hold these, and weights explicitly can't. So weights will hold, we'll read those other parameters off of weights. Okay, can't move that. This is gonna get moved to the bottom, of course. Thank you, PyCharm. Nah, kidding. We love you. We love you, PyCharm. Yo, sponsor me, PyCharm. Yeah. Alright, dudes. So, okay. The weights we're gonna pass in, and that's gonna encode these output, these like constants for the outputs, right? So we're gonna pass this data structure in, so you don't have to power or pass. We will pass those in, but they're gonna be optional and they're gonna have defaults. No, they're just gonna have defaults. So weight ranges. So this is gonna be a tuple of tuples of int to int. Now that's the type. So alright, so
follow me. Been waiting for you.
I guess this isn't weight ranges, this is like power ranges. Nah. Output ranges? Yeah. We can get to naming, we can name that later. Alright, so let's do so we're gonna use iter_tools. So all values from iterable output ranges. This needs to be a list because we're gonna iterate over it twice. I'm gonna have to implement from iterable, because I know that's not built in MicroPython. So we're gonna do min output max, oops, max output. All right, so yep. Alright, so enumerate weight ranges. So this is output ranges. This is a float. This is a float. 0.0, 1.0. Okay. Alright, so we got, this is a float. Power min. This is a float. Power max. All right. This is the tough one. Potential values is the tough one. So these are the like speeds that right. This is pretty important. Alright, let's set this up to run. Alright, so lines equals. I'm just gonna run this and see what happens. Output ranges. Weight ranges. Where's the CPU at? It's going high. That's because of this right here. There are a shitload of potential values. Which is bad. So there's gonna be a lot of combinations. Potential combinations. So that's the thing we got to figure out here, is how to limit the number of speeds. CPU pegging 100%, bro. Yeah, because if we stop this, right here, speeds 3,000. So the target counts. It's so many. It doesn't really make sense. Wait, where does this come from? Okay, that's in. That's in the fake zone. So we want to, okay, so what we're gonna have to do is figure out a way to provide like a number of speeds, a number of possible fan speeds, and then make sure that the target is like evenly divisible into one of those. So this step, so let's work through that right now. So if we do this difference, num speeds. This gives us steps. Alright, so So that's wrong. Already found any bugs, baby. Yep. So you have to make sure that these speeds can make up, like we can get to that target count with these different speeds. I guess we'll just try it out. Oh. That was fast as fuck. Oh. Huh. Is that always gonna work? Is that always gonna? Okay. I guess we're leaving a little bit of a resolution on the table, but wow. Ooh. Huh. Weight and speeds. Do weight and speeds 0. Sorted. So how do you expected one argument got to sort? Wait, this means sort. Yep, that's where it goes. Oops. Where did that go? What? Huh? What? Huh? What? Why is this not working? Okay, so let's just try printing. Print, weight. Weights and speeds, weight and speed. Okay. So okay, maybe I see. Weights and speeds. Are some of these none? Oh, you know what? Okay, so wait, this is wrong. So this is max output. Yep, that makes sense.
I don't see bullets.
There's gotta be a stool or something.
I just see opportunity. And I see opportunity cost. And I see the opportunity that costs me, costs people a quarter as much.
Nah, that's alright.
And that's generous.
Do you wanna sit on my knee?
Do you want to sit on our knees? We can like put our knees
we
together.
can share knees.
I don't know, man. I got
Can't sit on
glowing
my knee.
cheeks, bro.
Yeah, an individual fan can't spin that fast. Damn, what's going on, chat? What's going on? Camera's a little high. Kind of him looking up, which is a little bit silly. Alright. Alright, so let's just do weights and speeds. So let's just get all the weights. Am I missing something here? Why is this not working? This looks sorted now. What? Alright, so so if the target's 4,500, yeah, this makes sense. So one of them is in, oof, that's a little harsh, eh? So we'll have so what if we do 100 speeds? What about 500 speeds? Oh yeah, starting to chug. Yeah, so now it's a lot of numbers. I think that it will most likely be fine at like 100 speeds, 200 speeds. It doesn't need to be infinitely variable because that makes it harder to optimize this. I think I'm generally happy with this result though, at like 100 different speeds per fan. Yeah, let's take weight ranges and not do it up here. Yeah, so it's still like the same noise level. Yeah, the more you're able to, more combinations you're able to check, the slower the whole thing is gonna be. But I guess that's me being ooh, why is this slow now? Or 100 was faster? Yeah. So this is the lazy part. This is the 80% part. Is limiting each fan to only have 100 different speeds. Technically they could have way more, but for ease of doing this, that's what we gonna do. Alright. So let's graph this bitch. Actually, wait, let's try more realistic numbers. $20K. $40. $41. 50. And then this last should be like at last resort. Use this speed. Yeah, so this is the problem. So there's no way to add those three numbers that sucks. So there's no way to add this, in this case, there's no way to add the speeds together to get that target, to get the target count. So what if we say target counts is like a rounder number? Like, what if we fuck with this a little bit? So what if we input step here? So step size. So if it's in one step of target value, then it's added to the group. That's definitely a way of getting more resolution. So if we do so if plus step size not target value, it's target value, so it's target range. So target min equals target value minus step target max target value plus step size. It's greater than target min and less than isn't it like this? This is equal on both sides. Alright, let's see if we get more values here. Nope, I forgot to add that one. Step size, step. Okay. There we go. Fuck. Nice. So that's tons of options. Maybe too many options. Nice. Look at that shit. So it's close. Alright. It's like a couple hundred counts away. It's like... Nice. That's like nothing. Alright, this is gonna work. This is totally gonna work. So what was V again? So it was... Wow, so that's pretty quiet. 50% power. And each of the fans, oh. Wow, I'm really happy with this. So at 50% power, alright, so let's try the one case. Yep. Awesome. Full speed. Full motherfucking speed. Alright, the zero case, they should all be... Zero, zero, zero. I guess that's not totally right. So... There's gonna be a value here, call it 1,000. Ah. Oh, I guess that's fine. Yeah, there's gonna be a minimum amount that it's able to spin at, because it always has, one of the fans always has to be spinning somewhat. Dude, I'm pleased with this. I'm very pleased with this. So loosening this requirement loosening this requirement gives us way more options, and it's usually within rounding distance of what we want, and we can add a lot of stuff there too. We can add more steps in here to make it harder or less likely for it to spin up. But at 50% power, this thing is going to be silent. And we could probably add more steps. Right, if we do this, if we do like make that hump harder to get over. You got two barely over it, or one over it and two barely over it. Yeah. This is great. I love this so much. Alright, so we're going to call that tolerance. Alright, so this is great. This is so great. All right, so next is on to visualizing this. So I'm going to commit. Introduced tolerance to, what's that function called? Okay. Awesome. No value for tolerance. Test fan speed control. Yeah. I'm not even using that function right, or that thing right now, but that's okay. Okay. Function missing $string. Queue it. Okay, I have to piss. BRB.
Online training for in-demand jobs. They're developed by Google, taught by Google, and made for you.
So we're gonna work on
I'm back. Oh, ouch.
Follow me. Been waiting for it.
Alrighty. Heard this one already. Heard this damn beat tonight. Heard it. Oof. How does this sound? Let's do a sound check. Sound check. My voice is clearly audible over the music. Maybe a little down. My voice should be clearly audible over the music. Yeah, absolutely is. Alrighty, so let's visualize it. Let's get in here, dude. This function name sucks. Alright, so we're just gonna want to do a standard matplotlib. Let me pull up the matplotlib dockeroonies, dockeronos. Yikes. Move you over here. Bang, 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 bang. Oops, fuck. Matplotlib sample. About as simple as it gets. So we're gonna do so how do I want this to look? Maybe I could pull. Nah, that should be there. That should be in there. That should be in there. So we basically want to sweep across this. Alright, I'll add a numpy. LMN. Okay, so what I'm trying to do here is sweep through the different powers to get different ranges. So to get the different individual fan speeds. So I guess that's easy enough. So we'll do So we want to take this thing. Yup. For power in powers. And we want to fucking do this shit. Ooh, that's slow. Okay, that's kind of being slow. That's a little bit scary. Who are you having trouble with? Should I log this? Computing power. Alright, so let's see if this is one individual thing or if each of them are taking a bit of time. Yeah, it's just each of them take a little bit of time. Yep. That makes sense. I wonder if this is gonna be slow as fuck on MicroPython. I guess this isn't that slow of an update rate. It seems to be at least constant in time, right? Can't say who. Yeah, it looks kinda. Damn, I don't wanna stop it and add timers because then I have to do it again. I wonder if there's caching in MicroPython. Because I'm sure... Yep. So... we want to unpack this sucker. Because we want to graph these individual lines. This one gotta get X'd. Bruh. So we got this list of tuples. Now we gotta make 3 lists. So, I literally think we just need a single asterisk here. I think that's literally gonna do it. Yep, that's it. X values is range LAN powers. Alright, so speeds, perf. So we've unpacked that because this is a list of tuples. We've unpacked that. So for fan speeds in speeds per fan, so this is so this is as the fan speed increases, alright, so let's do stacked bar. Stacked bar is going to be easier to see this. Can I do just tuples directly to stacked bar? Nope. I think that's what we gotta do. Which is funny. Aw, man, where the thing at?
Yeah, I used to watch from the shore, ignoring the pain that they cause. Some little drops seem to pour, warning those tips that they've lost.
I wish this was faster.
I've never climbed on a board, but I'm sure I'd learn it real quick. My balance has never been. Boxes to the left, a shadow box with this hit.
Yep. Right, so hopefully this makes it easier to see if there's improvements I could make. I'm not crazy about how slow this is. It doesn't have to be super fast. Nice. I guess that's wrong. And what's up with that guy? You know what I'm saying?
Long within the top percent secret. Friends and son of the must have made some lucky. Heard it all before. Is he gone at the door? No one's ever found he gone. Where's he gone? Wandered down the hall and intriguing us. Heard it all before. Is he gone at the door? Here gone is Choppy. Here gone is Choppy. Pushing on in into the tree. Until he saw he loves you. I've heard it all before.
Yes. Alright, this is a little bit... Okay, so it's way faster in debug mode, which is fucking just fucking with me. Why is this stack thing not working? Why is this stack not working? It could be just right. No, it starts pretty quickly. It starts adding the other ones in. Is this because of this? No. It's this bottom parameter. Interesting. What if I pass none here? Okay, so we'll do speeds per fan, fan index -1 if fan index is greater than 0, else none. This is shit. Come on, boys. Whoa, whoa.
I swear the world stands still when you're gone.
What if we only That's interesting. That made it look like it's probably the graph code's wrong. Yeah.
I got some wine in my cup, but it don't feel me like you do. I thought that losing track of time would mean the faster I move, but all the clocks turn the same, and the bigger issue remains. I swear the world stands still when you're gone. Nobody moves, nobody loves, nobody's dancing. But is an hour in a day if I'm so lost when you're away? All the clocks turn the same.
Alright, so
Issue remains. I swear the world stands still when you're gone. When you're lost, I swear the world stands still. I swear the world stands still. How's it you thinking? How dare you?
stacked bar
Feel the shift in my bones.
in loop matplotlib.
All I know if it scares you. Having all this control, do you wanna let it go? I got someone in my cup, and it don't feel me like you do. I thought that losing track of time would mean the faster it moves. Yeah, all the clocks turn the same, but the bigger issue remains. I swear the world stands still when you're gone.
I'm not talking at all. Maybe this is not good streaming times. This works. It works really well when you know. Oh my god. So this is the sum. Fucking dicks. So this is. Oh my god, that's so annoying. So this, you have to... I hate that. Okay, so... Okay, so it's gonna be literally, so okay, I got pause the music. It's that time of night where I'm losing power, dude. I need to focus on this shit. Alright, so the bottom, we have to calculate that every time. So it's basically the total sum of everything before it. So ugh. Alright, so this is basically the speed. Oh my god, my brain is fucked. Previous speeds is speeds per fan from 0 to fan index. So this is going to be a list of lists. So maybe this will work. So sum of values for values in zip previous speeds. Bonk. Unfortunately, gentlemen, I need a breakpoint. Oh, it's so much slower in debug mode. Why, God? Oh, God. And you hit to reprogram me. Just absolutely falling asleep. Come on, man, hurry up. Your enemy is a child. Okay. Any day now. I wonder why switching this into the debugger for this particular thing brings it up like an order of magnitude of the amount of time it takes to finish. If I understood more about this, I could answer that, but I don't. I hate to reprogram me. Okay. Where's my Python console? Jesus Christ. Previous speeds. So 0. Okay, okay, okay. What if we do that? Yes. Okay. That's it. So this shows that the fan, the blower, as it linearly increases in power, the individual fans Alright, see how they're all kind of cones? So that's, yeah, it shows the behavior we want. Alright, so the cone means it only turns on when it needs to. So at 50% power, maybe a stacked bar isn't the best way to understand how the individual fans move. Okay. Well, we got something. I'm gonna hop off stream. Thank y'all for watching. Peace, peace, peace.